Hello again. In this session, we will talk about acceleration. Now, so far, we have learned about distance, displacement, speed, and velocity. Now, acceleration is another parameter which is used to describe motion. I'm sure you've already heard the word acceleration. I want you to think about the context in which you've heard this word. I'm sure whatever you're thinking of involves something increasing its speed, right? Now, acceleration is not necessarily increase in speed. It basically means change in speed. So even a particle or a vehicle which is decreasing its speed is accelerating. But to differentiate them, that acceleration is called deceleration. So, acceleration or deceleration involve a change in speed. Now, by definition, acceleration is defined as change in speed by the time taken to bring about that change. And if you think about what you know acceleration instinctively, it is basically the same thing. You see something accelerating, what does it do? It changes its speed. Now, if you compare two bodies, let's say you have two vehicles, A and B, and they both start to accelerate. Let's say I tell you that B is accelerating faster than A. What do you think that would mean? That would mean that B is changing its speed more rapidly as compared to A. So this rapidness that we are talking about is basically in terms of time. That means in the same time, it will bring about a greater change in its speed as compared to body A. Right. So that is why we define acceleration as change in velocity by time. Right. So acceleration is also a vector. And so we could write that acceleration is change in velocity by time. We have discussed this before. Whenever you divide a vector with a scalar, the quantity remains a vector. Right. So we can be sure that acceleration is a vector quantity. And acceleration is basically rate of change of speed. Right. I hope you by now understand what we mean whenever we talk about rate of change. So acceleration is rate of change of speed. I'm using the word speed and velocity interchangeably here, but I'm sure you understand that acceleration, though, is a vector, but speed is also the magnitude of velocity. So we can sometimes use these words interchangeably. But strictly speaking, acceleration is the rate of change of velocity. So we should not call it speed, but rather velocity. Right. So let's take an example. Let's say that some body starts from point A. There it was at rest, so its speed was 0 meter per second. Right. It reaches a point B in 5 seconds, and at point B, its instantaneous speed, which means its speed at point B. So the instantaneous speed at point B is 10 meter per second. So this particle has moved from A to B in 5 seconds, and it has increased its speed from 0 to 10 meter per second. So in this case, can you find out the acceleration of this particle? It's fairly simple, right? We know the formula that acceleration is equal to the change in velocity. Now, the final velocity is 10 meter per second and the initial velocity is 0 meter per second. And hence, this value becomes 10 minus 0 divided by 5. So this becomes 2. Now let's think about the units here. The speeds which we are measuring are measured in meter per second. The time is measured in second. So the unit should be meter per second divided by second, which can be written as meter divided by second square. So the acceleration becomes 2 meter per second square. And meter per second square is the units in which acceleration is measured. Right. So you may have noticed that in this case, we did not take any signs into consideration. Let's take an example which highlights how sign is important. So let's say a particle starts from point A where it has a speed of 15 meter per second rightwards. And then say after 10 seconds, it reaches the point B, and at this point it has a speed of 5 meter per second but leftwards. In this case, once again, we wish to find the acceleration of this particle, right? So now, since we are dealing with vectors, let's first decide a direction which we are going to take as positive. So let's say that I say that this direction is positive. Right. Now, another thing to notice is that we are talking about change in velocity. Now, change in anything is always defined. Change in general for any quantity is defined as the final value minus the initial value. Right? So change is the final value minus the initial value. So when we write this term, we could say that A is equal to V final minus V initial, and we should use vector signs because they are all vectors. So acceleration is V final minus V initial divided by the time. So in this case, what is the final speed or the final velocity? It is 5 meter per second, right? But it points in the direction opposite to the direction we are considering as positive. So that means the final velocity Vf is minus 5 meter per second, right? This is because of the sign convention that we have chosen. Similarly, the initial velocity of this particle has magnitude 15 meter per second, and it points in the direction which we have taken as positive, and hence it becomes plus 15 meter per second. Right. Now we have the final and the initial velocity with their appropriate signs. So let's find acceleration. So acceleration becomes minus 5 minus 15 divided by the time taken, which is 10. So this becomes minus 20 by 10, which gives you minus 2 meter per second square. Now, let's try to see how the result would change if we change the direction that we have taken as positive. So let's now consider the opposite direction to be positive. Right. If this was the case, then acceleration, which is final minus initial divided by time, let's see if it changes. So, if this direction is positive, we can say that the final velocity is plus 5 meter per second. According to our new sign convention, this direction is positive, which means that the initial velocity is minus 15 meter per second, since it points in the direction opposite to the one we've taken as positive. Right. So now acceleration becomes plus 5 minus 15 divided by 2, which gives you an answer of plus 10 meter per second. The time we have taken as 2, but the time is actually 10 seconds, and hence this would be 2 meter per second square. Right. So here we see that our answer has changed. But we had discussed that sign convention should not matter. So let's understand this why. In the first case, we had taken this direction as positive. We got our answer as negative, which means that acceleration was in this direction. Right? Because since it is negative, it must point in the direction opposite to the one we have taken as positive. Right? In the second case, when we chose the opposite direction as positive, we got our answer as +2. So that means that the acceleration is in the direction that we have taken as positive, which tells us that the acceleration should be in this direction. So you see, in both the cases, though the sign of our answer is different, the interpretation remains the same. It gives us the same magnitude, the opposite sign, but still, when you interpret it, you get the same result. Right. So, I hope you now understand acceleration. Acceleration we saw is the rate of change of speed. To be more precise, it is the rate of change of velocity since acceleration is a vector. Now, with this, we have learnt about all the parameters that are used to describe motion. In the next session, we will learn about the equations of motion which relate all the parameters that we have learned. Thank you.